Well, greetings, everybody. It has come to my attention today that it might be good to do a variety of questions about the standard normal distribution and the z-score. Okay, so I have a selection of 5 questions from my math lab that I'd like to show you with regards to that. Before I do that, let's get an idea of the big picture. What you're looking at here is the standard normal curve. Okay, it is a normal distribution with a mean of 0 and a standard deviation of 1. The normal distribution on its own can have a mean, any mean and any standard deviation, but the standard normal has a mean of 0 and a standard deviation of 1. Now, in our class, we're interested in calculating probabilities, proportions, and things like that. And so there's two numbers with regards to this curve that we'll need to know about regarding that. So one thing is there's the area of a certain portion of the curve. So here, this part that's shaded in blue is the area of the curve that you see there that's shaded in blue. Here it says it's 0.36. Okay? The total area under the curve is going to be 1 if it's the standard normal curve. All right, but nonetheless, that is the area of the portion of the curve that you see there. That's one thing. The other associated number is the point on the x-axis or the horizontal axis that, if you look to the left of that on the curve, has this area. So in other words, at the point on the horizontal axis where we're at negative 0.35, the area under the curve to the left of that number is 0.3632. Okay, so this point on the horizontal axis has this amount of area to its left. That number is the area or the probability, and this number is called the z-score when we're talking about the standard normal curve. Okay, so that's the big picture. Those are the concepts that we need to be aware of if we're going to try to answer questions on my math lab. So let's go to my math lab. Here it says use the standard normal table, which we won't be doing. You can look these numbers up on a table, but thankfully we have technology, we have StatCrunch that makes this all a lot easier. So we'll use technology to find the z-score that corresponds to a cumulative area of 0.3680. Okay, so that sounds kind of like what I was saying, that there's the area and then there's the point on the horizontal axis that has that area to its left. So they're giving me the area and I need to find this number. So let me show you how to do that. We'll use technology, we'll use StatCrunch. So we're going to go here, we're going to go to StatCrunch. Once we're in StatCrunch, we're going to go to calculators and then normal. Okay, and what it brings up is the standard normal. See, mean of 0, standard deviation of 1. That's what I want. Now the z-score is the number on the horizontal axis that has the area 0.3680 to its left. So the way I find that is I say x less than, and I just leave this blank. This number will be the point on the horizontal or x-axis, and this number is what I want the area to be. So that was 0.368, and if I can put the 0. So if I put it in like that, the number that's going to show up right there is the z-score. It's the number on the horizontal axis. I put compute, and it says, okay, right here, shaded in red, okay, the area is 0.3680, okay, and this point right here on the horizontal axis is negative 0.33715, okay. So I put the area here, and this is the point that has that area to its left, okay. And you'll have to put x less than or equal to set it up like that, and that's how we want it. Okay, so now that's all I have to do. I put the area here, the z-score shows up there. Now I noticed that in my math lab it says round to 2 decimal places. Okay, so I got to take negative 0.337 to 2 decimal places. It's going to be negative 0.34, and so that's what I put in. All right. Okay, so that's how we find the z-score with StatCrunch. just know that when you stat crunch, this number is the area and this number is the point on the horizontal axis that has the area to its left. Okay, if you change this inequality to greater than, then it flips it around, and that's not the way that we want it. That's not what the z-score is, so go ahead and leave it like that. Okay, now I'm going to leave StatCrunch open because I wanted to show you a few others. Look at this one. It mentions like to look at a table and all that, you know, but we don't have to do it that way. We can use StatCrunch once again. So let's see. I guess all it's telling us is that this is once again the area. 0.048. Okay, all right, so I'm going to open StatCrunch again, and remember this number is the area. That's what I'm given, and I want to find the point on the x-axis that has that much area to its left. So type in 0.048, hit enter, and then I get that point right there, which is negative 1.66. Okay, I put negative 1.665. It said round to 3 decimal places, so negative 1.6645 to 3 places is negative 1.665. Okay, so that's the answer I put in. Let's look at a few more. Now here, this time they're just telling us a picture, right? But you know, we can understand it the same way. If you look a little closer at that picture, it says, well, here in blue, the area is 0.4129. The z-score would be the number, the spot on the x-axis or the horizontal axis that's right there. So that's consistent with what we've been doing. Let's open StatCrunch again, and this time, all right, area 0. Whoops, 0. What was it? 4129. Okay, so that number that has this area to its left is the z-score, and that's negative 0.220. Round to 2 decimal places, that's just negative 0.22. So that's the answer that I have there. Let's look at one more. Look at this one. This one's a little strange, but I still think we can understand it the same way. Here it's asking me to find this number and this number. This number, a z-score, has this area to its left, and then this number has this area to its right. Now, one thing about the normal distribution is it's symmetric. It's symmetric about the mean. So the mean right here, given that this is the standard normal, is 0. So it's symmetric. It's a mirror image on either side of that. So what I'm saying is, whatever this number is, it will be negative. This number will be positive, and it will be the opposite. So if this number was like negative 0.3, this number would be 0.3. So if I can find this one, take the opposite, I'll find that one. Okay, so let's do that. Let's open StatCrunch, and so I want to find the point on the horizontal axis that has an area of 0.0244 to its left, and I get negative 1.970. All right, so that number right there, negative 1.970. So negative 1.97 rounded to 2 places. But remember what I said, because of the symmetry on the normal distribution, that number is just going to be the opposite. So it's going to be positive 1.97. Okay, so that's why I put positive 1.97 in. You could use this to find it directly. What if I put, you know how like here it's saying, it's by pictorially it's saying, well, what's the point here on the horizontal axis that has this amount of area to the right? If I switch this around and I put this number in again, 0.0244, then look what it gives me. It gives me positive 1.97. So you could still switch the inequality around and answer it that way if you wanted to, but the graph is symmetric, and these numbers would have to be opposites of each other. Now, so far when I do questions 1 through 4, I'm just trying to get you acquainted with the numbers that we're concerned with on the normal distribution and how to use StatCrunch in particular to find them. Now here's an application though, like a problem where we would use a normal distribution and StatCrunch to solve it. So here is a normal distribution that represents a certain kind of data. It's the per capita energy consumption in kilowatt hours in a certain country for a recent year. Okay, All right, so it's like if you took all, all kinds of people use different levels of electricity, so on and so forth. Some use a lot, some use a little, some are kind of in the middle, and so on, like that. This curve represents how all that data is spread out. A lot of data has a normal distribution, meaning that most of it's in the middle, and the further you stray from the middle, the less of it there is. Like, so most people will be near the average. Very few people will use way more electricity than average. That's why the curve dips down to the right, and very few people use way less energy than average. That's why it dips down to the left, and that's why it's the biggest in the middle. It's a very rough description of the normal distribution. So reading the question, it says, what consumption level represents the 5th percentile? Now, the 5th percentile is the number such that you are more than 5% of the data, okay? So like, what energy usage is more than 5% of the data overall? Now, that sounds kind of like a probability, and I said that on the curve, the area could also be interpreted as the probability. So it's like, what are the odds that you use more than 5% of the population? So here's what I do. I notice that this is not the standard normal. It says it has a mean of 22,335 kilowatt hours, so I have to put that in. And it has a standard deviation of 576.2 kilowatt hours. Okay, so that's the normal distribution I'm using this time. And the 5th percentile, that's like saying that I want the area of the curve left of whatever number it is to be 0.05. 0.05 represents as a decimal 5%. Okay, so if this part right there has an area of 0.05, that means that 5% of the overall data is less than whatever this number is on the horizontal axis, which is 1387.2. Now it says round to the nearest integer or whole number, so that's why I put 1387. All right, so 5% of the area on this curve is less than 1387.2. That means if you use this amount of energy, 1387.2 kilowatt hours, you use more than 5% of the people in the overall data. Okay. What about the 20th percentile? Well, that we would just change this to 0.2. 0.2 in decimal is 20%, and I get 1850.0, so that's why I put 1850 kilowatt hours for that one. This next one sounds a little different. It says, what consumption level represents the 3rd quartile? Well, think of the word quartile or a quarter. Like, what's a quarter? 25 cents. Okay. A quarter would be 25%. So the 3rd quartile, 3 times 25 is 75. So what they're asking here is what level of energy usage is greater than 75% of the overall data. So I want to set the area number, which is this number right here, to be 0.75, and I want to calculate the area of the curve left of that. Okay, so if you use 2,723.6 kilowatt hours of electricity, you use more than 75% of the data. That's how I can interpret this number. Over here, it's said to round to the nearest integer or whole number, so I would round 2723.6 to 2724. All right, so hopefully that gives you a broad tour, a broad scope of the basics of the normal distribution and how we do calculations. And really, we're just concerned with two numbers: the number on the x-axis or horizontal axis and the area that's to its left or right. Okay, and I've showed you examples of all of that here. Hopefully that's enough to take you through most of the assignment, but if you have any more questions, let me know.